Second part of the exercise, end of the chapter exercise, question number 10 to 16 we are doing. Question number 10 is, a rational number has a terminating decimal expansion whose last non-zero digit occurs at the fourth decimal place. देखिए what is given to you, last non-zero digit comes at the fourth decimal place. Suppose if x is equal to 0.b1, b2, b3, b4, then b4 is not equal to 0. This is given. So what is to prove? For show that such a number can be written in the form. To show it can be written as p upon 10 raised to power 4. Then p is an integer. Then is it necessary the denominator of this rational number when written in the lowest form is divisible by 2 raised to power 4 or 5 raised to power 4. So this is, let us do proof. X is equal to 0.b1, b2, b3, b4. This is let. So b4 is not equal to 0. This implies x is equal to b1, b2, b3, b4. I am removing the decimal, 1 with 4 zeros. Now, so this is x is equal to b1, b2, b3, b4 upon 10 raised to power 4. Let p is equal to b1, b2, b3, b4. So this is x is equal to p upon 10 raised to power 4. देखिए now b4, if this is number 1, b4 is not equal to 0 given, and we know that if any number is to be divisible by 10, it must be have 0 in the end. So but b4 is not having 0, so this implies, given, this implies b1, b2, b3, b4 is not divisible by 10, or p is not divisible by 10. Why not? Because p we have taken, p is equal to b1, b2, b3 and b4. So this implies x is equal to p upon 2 raised to power 4 into 5 raised to power 4. This number x is, so this is, if we write, so this is proved first shown x could be written like this, and if we write x in the lowest form, it cannot be cancelled, with both 2 and 5. क्यों नहीं कर सकता? Because 2 5s are 10 और 10 से वो divisible नहीं है. So this implies either 2 raised to power 4 into 5 raised to power 4 is divisible, either p upon 2 raised to power 4, 5 raised to power 4 is divisible by 2 or by 5 or not by anything. This implies if the two cases are there, if it is divisible by 2, then not by 5. If divisible by 5, then not by 2. देखिए मैं आपको एक एग्जांपल से बताती हूँ. सपोज आपका नंबर है 2134. 0 तो हो नहीं सकता ये. अगर यहाँ पे 4 है, दिस इज डिविजिबल बाय 2 बट नॉट बाय 5. इफ इट इज 2135, it is divisible by 5 but not by 2. I am applying the divisibility rule. 2137 not divisible by 2 or 5. So in every case this number will be divisible by either by 2 raised to power 4 or 5 raised to power 4. या दोनों से ही हो जाएगा लोएस्ट फॉर्म में, राइट. ये मल्टीपल्स तो होंगे ही होंगे इसके. उसने यही पूछा है कि when written in the lowest form is divisible by 2 raised to power 4 or 5 raised to power 4. So, when written in the lowest form, denominator is divisible by 2 raised to power 4 or 5 raised to power 4. Then question number 11. Without performing division, determine whether the decimal expansion of 18 upon 125 is terminating or non-terminating. So we know the rule. We will write the prime factors. Prime factors of 125 are 5 into 5 into 5. It has factors only 5. So it will be terminating. So when it is terminating, then next part of the question is, if it is terminating, state the number of decimal places. We need not to write in the decimal, but we have to tell after how many places of decimal it will remainder will become 0. So 18 upon 125 is equal to 18 upon 5 raised to power 3. So to put the decimal, we know very well what we do. We see how many zeros are there in the denominator. So I have to make here 10 raised to power something. 18 upon 5 raised to power 3 is already there. If I multiply this with 2 raised to power 3 in the numerator, 2 raised to power 3 in the denominator, does not make any sense. But this is equal to 8 into 18 upon 10 raised to power 3. So 10 raised to power 3 means it will terminate after 3 decimal places. It will terminate after 3 decimal places. Question number 12. A rational number in its lowest form has denominator 2 raised to power 3 into 5. How many decimal places will its decimal expansion have? Explain your answer. देखिए अगेन द सेम टाइप ऑफ क्वेश्चन. यहाँ 18/125 था, वहाँ पर हमें डिनोमिनेटर दे रखा है, एक न्यूमिनेटर का कुछ नहीं दिया हुआ. सो लेट x be numerator only to make it simplified. X be numerator. Nothing to do with it, only to write. So this is equal to x upon 2 raised to power 3 into 5. Again to see the decimal places, I have to make 10 zeros in the denominator. So x upon 2 raised to power 3 into 5. 1 5 is already there. I have to make this 3. So I will multiply by 5 raised to power 2. If I am multiplying this 5 raised to power 2, I will multiply here also. This is 5 raised to power 2 x upon 2 raised to power 3 into 5 raised to power 3. This is 25x, x could be any number, upon 10 raised to power 3. So it will be terminating. So decimal expansion may write in the same language as asked in the book. If it terminates, this question was, how many decimal places will its decimal expansion have? So its decimal expansion will have 3 decimal places. 3 decimal places, right? Now next question is question number 13. Very easy but looking very difficult. Try to understand this each and every point. Now he is saying a is equal to 7/12, b is equal to 5/6. First part is express both a and b in the form express k1 upon m, k2 upon m, where k2 minus k1 is greater than 6. He is saying make the denominators equal, but k2 minus k1 must be greater than 6. This is the question. So first, if I am making the denominators equal, 12 will be there. Let me try this thing. A is equal to 7/12. LCM is 12 and 6 is 12. So this will remain as it is. And 5/6 is equal to 5/6 into 2/2. This is 10/12, right? Now 7/12, 10/12. अब आपका k1 हो गया 7, k2 हो गया 10, m हो गया 12. But this is not the solution. Why not? But k2 minus k1 is not equal to 6. तो ये तो 6 के इक्वल भी नहीं है. What was he saying? It should be greater than 6. So let me write is not greater than 6. So I have to try something else. I will make the again coefficients equal. So let me make. I can make its denominator 24. If I am multiplying by 2, I am multiplying by 4, it will become 48. I am multiplying this by 6. Okay? So this 7 by 12 is equal to 7 by 12 into 6 by 6. 42 by 72. 10 by 12. 10 by 12 into 6 by 6. 60 by 72. So now two numbers are there, 42 upon 72 and 60 upon 72. K2 is equal to 40. K1 is 42. K2 60. M is equal to 72. All integers. First condition complete. Second is K2 minus K1. This is equal to 60 minus 42 is equal to 18. So K2 minus K1 is greater than 6. Second condition is also proved. Now the next part of the question is, he is saying write 5 distinct rational numbers lying between A and B. What was A? 7 by 12. B was 5 by 6. Keeping an integer numerator. Explain why the condition K2 minus K1 is greater than n plus 1. देखिए, now we have to write 5 numbers between A and B. देखिए, it means the 5 numbers between 42 and 60. We will be changing the integer in the numerator only, denominator will be remain the same. So 5 rational numbers are (43 by 72), 44 by 72, 46 by, मैं 45 भी लिख सकती हूँ, कुछ भी लिख सकते हैं हम, जरूरी नहीं कि आपने एक एक स्किप करके लिखना है. आई एम राइटिंग ओनली नाउ 46 by 72. The next I am writing 49 by 72. Next is 51 by 72. So many other. 18 is there, K2 minus K1. So I am able to write 17 numbers between them. So now the question is, why K2 minus K1 should be greater than 6 to write the numbers? देखिए, it is must. Explanation we have to give. Okay, if explain why the condition K2 minus K1 is greater than n plus 1. Now, to write rational numbers, rational numbers between any two given numbers, the difference of numbers must be one more than the numbers required. देखिए, आपको याद होगा कि जब हम फ्रैक्शन के सम्स भी करते थे बहुत आपकी जूनियर क्लास में, तो अगर हमने 7 नंबर लिखने, यू वर मल्टीप्लाइंग बाय 8 by 8. आपको 5 लिखना, यू वर मल्टीप्लाइंग बाय 5 by 5. अब टू राइट 7 rational numbers between 2 and 3. What were you doing? 2 upon 1 into 7 by 7. 7 लिखने हैं तो 8 by 8 और 3 by 1 into 8 by 8. जितना नंबर आएगा उसमें आप 7 नंबर्स लिख दोगे. Denominator will be 8. So he is asking why this is the rule we know. And why it is so, देखिए एक बार मैं आपको explain भी कर देती हूँ. Suppose I have to write 4 numbers between 10 to 14. डिफरेंस तो 4 है, बट आई एम एबल टू राइट. क्या लिख सकती हूँ? 11 लिख सकती हूँ, 12 लिख सकती हूँ, 13 लिख सकती हूँ. तो हमेशा एक उससे कम ही लिखा जाता है. तो मुझे यहाँ पर अगर 15 होगा देन आई एम एबल टू राइट 4 नंबर्स. Similarly, in 6 to 10, how many numbers I can write? I can write 7, 8, 9, 3 numbers. Difference इनका 4 है, but number, counting number उससे एक कम है. So this thing we will be writing in the explanation. Explanation will be in शेयरिंग डिनोमिनेटर में, जब आपका डिनोमिनेटर इक्वल है, डिनोमिनेटर ओनली इंटीग्रल पार्ट of numerator is changed. So to fit n numbers between k2 and k1, we must have k2 minus k1 minus 1 is equal to n. तभी आएगा. तो k2 minus k1 is equal to n plus 1. तो डिफरेंस अगर आपका n plus 1 होगा तो उतने नंबर आ जाएंगे, लेकिन अगर उससे ज़्यादा होगा तब भी तो उतने आ ही जाएंगे ना. अब सपोज आपने 10 और 20 में आपने 4 नंबर लिखने हैं, यू आर एबल टू राइट. पर 10 और 14 में 4 नंबर लिखने हैं, आप नहीं लिख सकते. 10 और 15 में लिख सकते हैं पहला, तो फिर 10 और 15 में भी 4 लिख सकते हो, 10 और 16 में भी लिख सकते हो, 10 और 17 में भी लिख सकते हैं. सो दिस एम्प्लाइज k2 माइनस k1 शुड बी ग्रेटर देन और इक्वल टू n. ज़्यादा होगा तब तो नंबर आ ही जाएंगे, लेकिन अगर उससे n plus 1 से कम होगा तो नहीं आएंगे. सो क्वेश्चन नंबर 14 इज 3 rational numbers x, y, z satisfy rational numbers x, y, z are given such that x plus y plus z is equal to 0 and xy plus yz plus zx is equal to 0. To prove this is only possible if x, y, z are simultaneously जीरो. मतलब अगर ये तीनों जीरो होंगे तो ही ये पॉसिबल है. प्रूफ देखिए, x प्लस वाई प्लस जेड होल स्क्वायर इज इक्वल टू एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर प्लस 2 इंटू एक्स वाई प्लस वाई जेड प्लस जेड एक्स. Substitute the values. 0 square is equal to x square plus y square plus z square plus 2 into 0. This implies x square plus y square plus z square is equal to 0. देखिए, square of every rational number is positive. So this is only x square plus y square, x square, y square, z square are all non-zero numbers. Non-zero नहीं, non-negative numbers. Non-negative. देखिए अगर नेगेटिव होता तो क्या होता कि अगर हमने 3 नंबर का सम करना है तो पॉसिबिलिटी थी ना कि आपका 2 पॉजिटिव है, उनको ऐड किया, तीसरा नेगेटिव, उसके साथ कट गया, आंसर 0 आ गया। पर अब तो ये तीनों ही पॉजिटिव है, तो व्हेन इट इज पॉसिबल एक्स स्क्वायर, वाई स्क्वायर, जेड स्क्वायर देयर सम विल बी पॉजिटिव। 0 कब हो सकता है? इट इज सो एक्स स्क्वायर प्लस वाई स्क्वायर plus z square is equal to 0 is possible only if x is equal to 0, y is equal to 0 and z is equal to 0. Otherwise it is not possible. Proved. Now next question is question number 15. We have to prove that a plus b upon 2 lies between a and b. That rational number a plus b upon 2 lies between a and b. Proof: a and b are rational numbers. Let a less than b. So adding 1 to both sides, इसका नंबर 1 कर दो, adding a to both sides of 1. So a plus a is less than b plus a. This implies 2a is less than a plus b. b plus a could be written as a plus b. So a is less than a plus b by 2. This is number 2. Now a is less than b. A is less than b. Now adding from 1, adding b to both sides. To both sides. क्या आ जाएगा आपका? a plus b is less than b plus b. So a plus b less than 2b, a plus b upon 2 less than b. Number 3. Number 2 says a less than a plus b by 2 and a plus b less than b, number 3 says. So from 2 and 3, a less than a plus b by 2 less than b. देखिए अब 4 is less than 5 is less than 6. It means 5 lies between 4 and 6. So a less than a plus b by 2 less than b. So this implies a plus b by 2 lies between a and b. In this question, spiral is given to you. We have to find the length of the hypotenuse. So how the spiral is made, I am telling you first this thing. This length OA 1 unit, perpendicular here, this is B 1 unit, then OB is joined at the point B. Again a perpendicular is drawn, 1 unit is cut C point, फिर आपका OC को ज्वाइन करा, अगेन C पर आपका 90 डिग्री. क्वेश्चन इज टू मेक join this. This is 1 unit. Now this point is D. There are 10 triangles given to you in your book. Question number 16 is spiral is given to you like this. OA 1 unit, OB is 1 unit, then BC is 1 unit, CD is 1 unit, ED is 1 unit. Like this 10 triangles are given. Question is to find the length of each hypotenuse. This is figure number 3.14, page 66. So question is, now in triangle we will be using Bodian Pythagoras theorem to find the hypotenuse. So in triangle OAB, so in triangle OAB, OB is equal to OA square plus AB square by Bodian Pythagoras. So this is equal to 1 plus 1 is equal to under root 2. So length of this is under root 2. Now in triangle OBC, OC is equal to OB square plus BC square. This will be equal to under root 2 square plus 1 square. This is 2 plus 1 under root 3. So this length will be under root 3. Now we will find the length OD in triangle OCD. OD is equal to under root 3 square plus 1 square. This is 3 plus 1 is equal to under root 2 लिख सकते हैं हम इसको, but we will remain keep it as it is. So the length of hypotenuse are, देखिए अंडर रूट 2, अंडर रूट 3, अंडर रूट 4, थर्ड ट्राइंगल में 4 आया है, तो फिफ्थ में अंडर रूट 5 आएगा, फिर अंडर रूट 6. सो द लेंथ ऑफ similarly we will find other lengths. So length of hypotenuse are under root 2, under root 3, under root 4, under root 5, under root 6, under root 7, under root 8, under root 9 and under root 10. So these are the length of the hypotenuse. So with this sum we have completed this exercise. Actually this chapter, the word of numbers, is completed, and if you have seen all the videos, and have done the practice. So write done in the comment. Write done in comments. If you are having any problem, then write that also. Give your problem. And do not forget to chapter 3. Now we will meet you in the next chapter in the next video. You must एक बात कहूँगी आपको कि अच्छे से आप अपना रिवाइज करिए. टेक द हेल्प ऑफ नोट्स. कोई भी प्रॉब्लम आती है मुझे कमेंट करिए. आई विल बी वेरी हैप्पी टू टेल यू एंड टू सॉल्व योर प्रॉब्लम्स. राइट. ये मत सोचना कि आप नहीं कर सकते हो. एवरीबडी इज एबल टू डू. सो मिलते हैं नेक्स्ट वीडियो में विद द नेक्स्ट चैप्टर. थैंक यू.